Okay, so for the following circuit here, we have to find IT and VT. So let's view the circuit when t was less than 0. So when t was less than, okay, so we have the unit step function here, and it's going to be 0 when t is less than 0, and it's going to be 1 when t is greater than 0. So when t is less than 0, obviously that's going to be just an open wire. We're going to also assume the circuit looks like this for a long time, so that means the place where the capacitor is also going to be an open wire, and then the inductor region is going to be short circuited. So obviously the current is clearly going to be 0, and then the voltage at the current passing through the inductor is going to be 0, and the voltage at the capacitor is going to be 0 as well. Okay, so we have those two dotted down. Now let's view this when t is greater than 0 or equal to 0. So we have our current source, we have our capacitor, and we have our inductor. Okay, so what we're going to do now is view the circuit. Since we have this current source here, and wait, hold on, let me just write the values in first. Alright, so we know that, so the voltage at this whole region is going to be just V, the voltage at the capacitor. And we're going to view this circuit we're going to view this circuit as a transient circuit, which does not include any sources. So recall we have a current source here, so we're going to just ignore that for now. And we're just going to write the nodal equation. So this is just I, and this is I1. So what this will look like is pretty much C dV over dt, that represents this one, plus I, which is just this one. Okay, so right now we're just trying to find we're trying to find IT. We're trying to find the current passing through here. So what we're going to do is we have to substitute something in for V to have everything in terms of I. So we know the voltage at this inductor is going to be the same as the voltage here. So V is equal to the inductance times the change in current over the change in time. So we can put that V into here. So it'll be C times L times d squared I over dt squared plus I. Okay, equals 0. Now divide everything by LC. And let S equal di over dt. So this is S squared plus 1 over LC. So alpha is going to be 0 because it's whatever is being times by S. And there's no S here, so alpha is going to be 0. And omega is going to be pretty much the square root of this, which will just be the inductance is 5 times 0.2, and that should give you 1. So alpha is less than omega, so we have an underdamping circuit. So we're going to be using the following formula. Current passing through the inductor is going to be equal to e to the power of minus alpha t times a1 cos wd, the damping frequency, plus a2 sine wd times t. Wd is going to be the damping frequency, so to figure that out, we're going to get the roots of this quadratic. So we're going to use the following formula. So after using the quadratic formula, you should get something like this. So alpha is just 0. This is just 1. So it's just going to be 1j. So damping frequency is whatever is being times by j, which will just be 1. And alpha is just 0. So we literally just have the following. Okay. So recall when t was 0, our current was 0. So this will just be the following. So A1 is just so A1 is going to be 0. Wait, sorry. Not yet, sorry, I made a mistake. My apologies. This is your transient current, because recall we are ignoring this a current source, and to get the actual IT value, it's going to be our transient current source plus our steady state current source. Okay, so right now, since we ignored the current source here, uh, we only have the following. Hold on, sorry. Okay, so we only have this following, so that's our transient current source. To get our steady state current source, we have to view the circuit when t goes to infinity. Okay, so we include back our current source. So the capacitance, it's an open wire, and the inductor, it's short circuits. So the current passing through here is going to be our I at infinity, and our current source was 12. So that means our I of infinity is 12, and that's what's equal to ISST. Okay, so we just have to add ISST to this, and that will give you our IT value. So this was just 12, so we just do that. Now, we're gonna, so we have, so we're viewing this when t is equal to 0, so our current was 0 at that time, times equals A1, and this is just 1, this is just 0, plus 12, so A1 is equal to minus 12. Okay, so that's the first bit done. I'm just gonna, move all of this to the side. Now, we have to find our A2. So I'm gonna differentiate all of this. So this is now minus 12. So minus 12 times minus sine t. This negatives obviously go away. Plus A2 cos t, and then 12 turns into a 0. Okay. Now we have to find di over dt, and we can actually find that easily. So we can just use the following formula. V over L equals di at 0 over dt, and we actually know the voltage at this capacitor, at this inductor. It's going to be the same voltage at the capacitor, and the voltage at the capacitor obviously can't change instantaneously, so when t was equal to 0, the voltage at the capacitor was 0, and that's the voltage at the inductor, so this is just going to be 0. So this is all just 0. So this is 0 plus, and this is equal to 0 plus A2, so A2 is going to be equal to 0. So now our IT will just look like the following. 12, sorry, minus 12 cos t plus 0 plus 12, and that's your answer for IT. Now, to find, what do you have to find next? We have to find the voltage at the formula for voltage at the capacitor. So pretty much it's just going to be voltage equals the inductance times the change in current over the change in time, because recall the voltage at the capacitor is the same as the voltage at the inductor. So we could just use the voltage as passing, the formula for voltage passing through the inductor, and that's going to be your voltage passing through the capacitor. So V is equal to the inductance value, which is 60, times the derivative of all of this. So it's just going to be minus 12 times minus sine t plus 0, and that's just going to give you, wait, sorry, not 60, my bad. It was 5, okay, and it's 60 times sine of t, and that's your final answer.